In one of our previous lessons, I taught you how to graph a quadratic equation in standard form, and the method that I showed you was to find the vertex, and then what we did is we used a table of values. We're still going to do that in this lesson, but I'm going to add on one extra layer, and that is to find the x-intercepts and also how to find the y-intercepts. Okay, because that's something that your teacher might be talking about in class, and so I'm going to add that in now. So if you haven't watched my lessons on how to draw quadratic equations in standard form using vertex and a table of values, then go check that out first and then come back to this one, and then we can use, or you could stay here, I guess. I mean, it's this, I could teach it to you right now as well. It depends on if you have enough time or whatever. So let's go for it. So what we're going to do, so this is called standard form. Remember that when it's written in the form ax squared plus bx plus c. So to draw a quadratic, which is something like this, you always need to find this little vertex. And let's go find that first, okay? So we're going to go find the vertex. So remember, to find the vertex when it's written in standard form, you have to use the formula. So I was going to say turning point over here. I don't know why I was doing that. But you're going to use the formula x equals to negative b over 2a. So negative b, so b is this number here. So you're going to say negative 16 over 2a. Now a is negative 2. Okay, and so that's going to give you negative 16 over negative 4. And so that's going to give us positive 4. Okay, now to find the y value, because that's your x value of your vertex. Now to find the y value, you take that x value and you go plug it into the place of x. So you literally just going to go y equals to negative 2 and then in brackets 4 plus 16 times 4, take away 30. Take away 30. And so if you had to go work this out, you end up with 2. So the x value is 4 and the y value is 2. So let's go plot that quickly. X is 4, y is 2. There it is over there. And now let's go do the whole table of values. So the way that you do that is you make a x and you make a y. Okay, and always put the vertex in the middle. So the x is 4 and the y is 2. Then because of the symmetry property, I want you to go one to the right and one to the left. Then go another one to the right and another one to the left. Okay, so that's what we've done in previous lessons. So then you can either choose to find the y values for these two, or you can find the y values for these two. So what I'm going to do is I'm going to go find the go find the y values for these two. So I'm going to start with the 2, and you're going to go plug that into your equation. So it's going to look like this. And so if you go plug that in, let's check what we get. We get negative 6. Okay? So that means this y value is also going to be negative 6. Why? Well, because of the symmetry property of quadratics, which I've spoken about many times. So we went 2 places to the left of the vertex, and we went 2 places to the right. So we went almost, you can think of it as 2 places to the right, 2 places to the left. So the y values are exactly the same. That's why I've got negative 6 and negative 6. You could go test me if you wanted to. You can go plug 6 into the equation, but you'll see that you'll just get negative 6. I'm now going to go plug the 3 in. So I'm literally going to replace all of this with a 3. And that's actually going to give us a 0. Oh, okay. So that's going to be 0 and 0. So that's quite awkward because I was going to show you the x-intercepts just now. But anyways, it's fine. I'll show you anyways. So we just got lucky. So there we've got 0 and 0. And, I haven't even plotted the negative 2 and negative 6. 2 and negative 6. There it is. And then 6 and negative 6. And so now we can draw it, but if you don't mind, let's not draw it right now. Well, actually, no, we can, sorry. What's up with this guy? Telling us we can draw it and I saying we mustn't draw it. Sorry, guys. Okay, so now what I want to show you. Okay, so that's how we used to do it in the previous lessons where I taught you how to use the vertex and the table of values. But what I never ever spoke about was, on many of the graphs I showed you, it just went like this, and there'd be like a little dot here, and a dot here, and a dot here, and a dot here, and a dot here. But what I haven't yet showed you guys how to do is how to find the x-intercepts, which is where it cuts the x line. Okay, so that would literally be this point here and this point over here, and then the y-intercept. So if you go like this and if you go like this, the y line is this one. The y-intercept, sorry, is this one over here. So that's your y-intercept. It's where it cuts the y line, and then those two green dots are called the x-intercepts. And I want to teach you how to find that now. I know we already have the two dots over there, but that was just out of luck. Most times that wouldn't have happened. So I need to teach you, or that's what I want to do now, is show you how to do that. And if we had to keep extending this line, eventually it would cut the y-axis. So I want to show you that as well. So I'm going to show you how to find the x values. Forget about the fact that we already have them. I'm going to show you how to do it mathematically, and then we're also going to show you how to do the y line. Okay, it's not difficult. So we'll start with the easiest one, which is the y-intercept. So think about a y-intercept for me quickly. If you look at any y-intercept, for example, let's say I have a quadratic, and it cuts there. If you look at the y, the place where sorry, I don't know what's going on. So if you look on the y-axis over there, what is the x value? Kevin, at 6. No, that's not correct. That's the y value. The y value is 6. But what is the x value? The x value is 0. Can we say that the x value is always 0 on this line? Think about that carefully. Yes, you can. If you look at any single place on this line, what is the x value? The x value would always be 0. For example, here the x value would be 0 and the y value is 8. Here the x value is 0 and the y value is 2. Here the x value is 0 and the y value is negative 2. So the x value is always 0 on that line. So if you want to find out where your graph touches this line, all that you need to do is just make the x equal to 0. So you're literally going to go to this equation and you're just going to make the x value 0. Okay, so that's going to be y equals to negative 2 times 0, plus 16 times 0, take away 30. And if you had to go work that out, you're going to get negative 30. So, okay, I don't have enough space, but this graph would go all the way down to, negative 30. That's where it would have cut the y line, okay? So the y-intercept would have a coordinate of x is 0, and then y is negative 30. Okay, so that would be your y-intercept. Now here's the more interesting part. I'm going to teach you how to find the x-intercept. Okay, so x-intercept. Now think about this. If you look at any place on the x-axis, okay, anywhere on the x-axis, the y value would always be 0. Think about that. I mean, if you look here, the x value there is minus 6, but the y value is 0. Over here, if you look at the x value, it would be 8, but the y value would be 0. If you look over here, the x value would be negative 4, but the y value would be 0. So what we can say is that the y is always a 0. So what we then do is we go to this equation and we make the y a 0. Like that. Okay, and now all of a sudden, I hope you've watched the lessons on how to solve quadratic equations, because this all of a sudden is a quadratic equation because it has that x squared. So I'm going to take everything to the left hand side. It's just more comfortable having the quadratic as a positive. So I'm taking everything to the left, and that would become plus 30. And so here we have it. Now what you can do first is always look for a common factor. So we take out a common factor first. Now a common factor here would be 2, right? So we take out a 2, and that would leave us with that. You don't have to take out the 2, but I advise it. And then you can just get the 2 away by just dividing it on the other side. So you'd end up with that. And so now we end up with that. And that's just a trinomial. So if you're good with your trinomials, you'd know that we now look at this number over here, and we write out all the different ways of finding 15. So that would be by saying, for example, 1 times 15, 3 times by 5. So if you use a 3 and a 5, you could easily make negative 8. How would you do that? Well, you would say negative 5, take away 3, because that gives you negative 8. So now what we're going to do is we're going to open up 2 brackets, And then what you're going to do is you're going to say negative 5 and negative 3. And then you're going to say x and x. And then you're going to say x take away 5 is equal to 0, or x take away 3 is equal to 0. And so x is 5, or x is 3. And so the x-intercepts would have to be where x is 5 and where x is 3. But we already knew that from the table, but that's just because we got lucky. It doesn't always work out that way. Most of the times it actually doesn't. Okay, so let's do another example now. Here's our last example. So what we're going to do is we're going to draw this, okay? But I want us to show a bit of everything. So we're going to show the vertex. We're going to find that. Then we can use the table of values. And then we can find x-intercept, or the x-intercept, and then the y-intercept. So to find the vertex in standard form, we must remember that we use the formula x equals to negative b over 2a. And so that's going to be negative, and then that's a negative 3 over 2a, a is 1. And that's going to give us 3 over 2, or you can think of it as 1.5. Okay? To find the y value of the vertex, you just take that 1.5 and you go plug it into each of those x values. So you're going to get 1.5 to the power of 2 minus 3 times 1.5 minus 4. And so if you had to go solve that, you're going to get negative 6.25. Negative 6.25. Okay, so x is 1.5, and then y is negative 6.25. So that's going to be like somewhere, it's a bit weird to draw, but somewhere like over there. Okay, so we've done the vertex. Nice. Now let's go get the table of values. Your teacher might even skip out on the table of values. This is always a bit of a interesting one because some teachers show it, some teachers don't. So in my videos, I'd rather include it, but you could definitely skip that step and you would still be able to draw it by just using those over there. In fact, I'm going to skip that for now, but I will add it in later at the end. Okay, I will add in the table of values, but I'll show you that it's not necessary. I'm just showing you everything. So let's go find the x-intercepts. Can you remember how to do that again? Well, remember your x-intercepts are on this line. And on this line, the y values are always 0, no matter what. On this line here, the y values are always 0. So remember that. To find x-intercepts, you make the y 0. So we're going to say 0 equals to x squared, take away 3x, take away 4. And then that's a quadratic. So you're just going to factorize. Now that's a trinomial. So you take the number 4 and you write out all the different ways that you could make 4. You could say 4 times 1 or 2 times 2. Now we're going to use the 4 and the 1 to try and make minus 3. So we're going to use 4 and the 1 to make minus 3. How would you do that? Would you say 4 minus 1? No, because that gives you 3. But if you say 1 minus 4, then that would give you negative 3. So 1 minus 4 is negative 3. Let's just write that a bit better. 1 take away 4 is negative 3. And so what we can now do is make our two brackets. And that would be, so you say x and x. And then it would be negative 4, because the 4s are negative, and plus 1. And then what you do, because it's now equal to 0, you can just say that x minus 4 is equal to 0. Or x plus 1 is equal to 0. Let's write that a bit better. And so we end up with x equals to 4, or x equals to negative 1. So x is negative 1, and x is 4. Okay. So see how we've gone and plotted that on our graph now? So those are the x-intercepts. So at 4, and then at negative 1. Okay, so that's that. Now we need to go find the y-intercept. Now remember, the y-intercept is somewhere on this line over here. So to find a y-intercept, you, on this line, what do we know? We know that the x value is always 0. So you make the x value equal to 0. So if you go to this equation, if you go to this equation and you make the x value equal to 0, then that's going to give you this. And that gives you negative 4. So then we go onto our y-axis and we put a little dot at negative 4. You see, now with that information alone, you could technically draw this graph. Like you could go like that. and you could go like that. But some students or some teachers are still going to ask you to use a table of values. So you could, I'm not going to do it now, but you could go do that. You could go get your table of values, and you're probably going to end up with like a dot over there maybe. And then you might end up with another dot. But it's just going to help you to get the shape. But you can get the shape by just getting the x-intercept, the y-intercept, and the vertex. So I sort of show a bit of everything, but you just got to do it the way that your teacher shows you guys in class.